All right, this is Mr. Werrick, so I'm going to walk you through this review pretty quick. I'm going to go ahead and write my SOHCAHTOA. So understanding how these interact, we have sine is equal to opposite over hypotenuse, cosine is equal to adjacent over the hypotenuse, and tangent is equal to opposite over adjacent. So let's start. This is just like how we're going to do at the start of the test. So express the sine, cosine, and tangent of angle x. So sine, cosine, and tangent. Again, the sine is the opposite over the hypotenuse. So from angle x, here's my opposite, here's my adjacent, and this one out here is my hypotenuse. So the sine is going to be 28 over 35. I don't care if you reduce it. You don't have to make me happy for this, and you won't have to on the test, even if it's radicals or whatever. The cosine is the adjacent over the hypotenuse, so 21 over 35, and the tangent is going to be 28 over 21, the opposite over the adjacent. Over here on this one, just apologize for it kind of going out of focus there. The sine, cosine, and tangent of A. The sine of A, opposite over hypotenuse, so that's 16 over 34. The cosine is the adjacent over the hypotenuse, so 30 over 34. And then the tangent of A, opposite over adjacent, is going to be 16 over 30. Sine, cosine, and tangent is Z. I'm looking at the same triangle here. So the sine is the opposite over the hypotenuse, 21 over 35 this time. The cosine is the adjacent to Z over the hypotenuse, so 28 over 35. And then the tangent of this is going to be opposite over adjacent, so 21 over 28 this time. Okay. Over on this side, angle C, the sine is the opposite over the hypotenuse, so 30 over 34. The cosine is the adjacent over the hypotenuse, so 16 over 34. And the tangent is the opposite over the adjacent, so 30 over 16. The missing leg length to the nearest tenth, I have misplaced my calculator, so I'm just going to show you the setup on this. This should be Pythagorean theorem. So it's 4 squared plus 8 squared is equal to c squared, because my hypotenuse is always c. In this case, that's 16 plus 64 is equal to c squared. So that would be 80 is equal to c squared. So I'm going to take the square root. So whatever the square root of 80 is to the nearest decimal, that's what we're looking for. Same thing over here. 3 squared plus 6 squared is equal to c squared. So that's 9 plus 36 is equal to c squared. So that's 45 is equal to c squared. So whatever the square root of 45 is to the nearest decimal, that's going to give me the answer here on 8. On number 9, that's 7 squared plus 10 squared is equal to c squared. So these are not Pythagorean triples. We're going to get decimal answers. This is 49 plus 100 is equal to c squared. So 149 is equal to c squared. So whatever the square root of 149 is, 12 and some change, I think. On number 10 here, it's 3 and 7 this time. So 3 squared plus 7 squared is equal to c squared. That's 9 and 49 is equal to c squared. So 58 is equal to c squared. I'm going to take the square root. So the square root of 58, which should be somewhere between 7 and 8. So my decimal's there. Okay. On the back side of this, again, I don't have my calculator, so I'm not going to have exact answers here rounded to the nearest tenth, but I'll show you setup and what it is you need to do. So on this one, here's my angle. This is my opposite side. Here's my hypotenuse across from the 90-degree angle. So this is my adjacent. So this would be opposite and adjacent. It's tangent. The tangent of a 27-degree angle is equal to x over 10. In order to get rid of the fraction, I'm going to multiply both sides by 10. Always do that out front. So this would be 10 times the tangent of 27 to get you your answer. Make sure your calculator's in degree mode. On number 2, here's my angle. Again, out here, this is my opposite. Across from the 90, here's my hypotenuse. This is my adjacent. It's opposite and adjacent. This is going to be tangent. So the tangent of my 25-degree angle this time is equal to the opposite that I don't know over 10. So similar kind of thing here, multiplying by 10. So this is 10 times the tangent of 25 is what you would be able to type into the calculator to solve that out and get an answer. Over here on this one, here's my angle going across like this. This is my opposite. There's nothing there. Going across from here, this is my hypotenuse, and this is my adjacent side. Since I have the hypotenuse, I'm looking for adjacent. This time I'm going to use cosine. So it's the cosine of a 39-degree angle is equal to my adjacent side that I don't know over my hypotenuse of 7. This time, again, I'm multiplying by 7 to get rid of the fraction. So this would be 7 times the cosine of 39 is what I would type into the calculator and work from there. And then on number 4 here, I have a 46-degree angle. I go across like this. Here's my opposite side. Across from the 90, here's my hypotenuse. This is my adjacent side. So since I'm doing opposite and hypotenuse, this is going to be sine. So the sine of my 46-degree angle is equal to my opposite of 8 over my hypotenuse of x. So finally I have something different. I have an x on the bottom of the fraction. That means I'm going to swap this. Remember, the sine of 46 is a single term all by itself. So that's what I'm switching with the x. So this should be x is equal to 8 over the sine of 46. That would give me that missing side there. Make sure your answer is bigger than 8. You're not dipping into negatives or anything like that. You may need to reset your calculator to degree mode. On the word problems, I'm going to go play disc golf. On hole number 5, I throw my driver. It gets stuck in a tree. The tree is 125 feet from the tee box. So straight line of 125 feet. That's where the tree is. What a great tree. This is my right triangle. And use my range finder, and it's going to go in a straight line this way and say this is 135. How high up in the tree is it? Well, this is going to be a right triangle problem, and we're missing a side, so this is Pythagorean theorem. This time I have the hypotenuse, so this is my b. So it's 125 squared plus b squared is equal to 135 squared. So I would subtract my 125 squared from both sides. So I get b squared is equal to, I don't know, big number. Again, I don't have my calculator, but whatever it is, it's the square root of 135 squared minus 125 squared, and that will take care of my squared here if I take the square root to the nearest tenth, so 1 decimal place, and figure that out. I think it's somewhere around 50 feet up. So yeah, that's going to be tough to get back. Then the last one, Frank is playing baseball. I've always needed a nice image with this one. So if you can imagine with me, for those of you that don't play, a baseball diamond. Here's our outfield. So we've got the third base side, the first base side, and then second base out here. Terrible drawing, but you get the basic idea. So he hits it over the right field fence, so it's coming out this way. And this is a 25-degree angle, and it says he walks this 90-degree angle 100 feet to get to where his ball is. Okay, so when we're doing that, again, it wants to know how far the ball went. So we go from here. This is my opposite side. This is my hypotenuse. I'm missing my adjacent. So if it's opposite and hypotenuse, I'm going to use sine. The sine of my 25-degree angle is equal to my opposite side of 100 over my hypotenuse. Because the x is on the bottom, I'm going to swap these out. So x is equal to 100 divided by the sine of 25. I think it comes up 236 point something feet. So this is definitely like a little league kind of field. Hopefully that gets you in the right spot. Don't forget tomorrow's test. It's not multiple choice. It's all going to be answers, kind of like what we were doing here. You'll have numerical answers. Again, on these first ones, it doesn't matter to me if you reduce this or not. Just kind of the setup is what's important to me there. And hopefully that gets you through your test. Thank you.